I would suggest writing down when substituting, use parentheses. And you're going to want to have your calculator out. Calculators make life a little bit easier. So, you're going to have that calculator out. And we are going to substitute these values.
Fuck, you're so blue. You're so blue.
This is Molly. Yes. 12, 17. Okay. So, grab your calculator, and we're going to fill in this table. My equation is y equals x squared plus 1. So you're going to grab your calculator. Can I borrow that for a second? And instead of x, you're going to substitute -2. So you're going to put -2 in for x. So -2 squared plus 1. And again, when you substitute a number, the number that goes into the problem should always be put inside parentheses. It makes it easier. You do not make as many mistakes if you use parentheses. -2 squared plus 1. The answer is 5. I want you to continue to fill in that table. So you are using the calculator to fill in that table. So,
I'm confused how you got that.
-2 goes in for x. -2 squared plus 1 was 5. Now we're going to do the next one. Instead of x, you're going to put -1.
Wait, how'd you do that? I'm so confused. Oh, Lord.
So again,
I'm stuck in this one. I don't know how you do
press the parentheses, because we're doing x squared, but my x value is -1, so I'm going to put -1. Then I'm going to press my squared button next to the 7.
What?
Next to the 7.
What?
Plus 1. -1 squared plus 1 is 2. I'm going to do it again. This time instead of x, what number am I putting in? 0 squared plus 1 is 1. Then I'm going to do 1 squared plus 1, just 2.
Oh, you're so smart.
And then I'm going to do 2 squared
Plus 1.
plus
5.
1. Now I'm going to graph it. Let's see if it makes a line or not a line. So -2, 5. -1, 2. 0, 1.
Wait a sec. What?
1, 2. And 2, 5. So this is the graph.
That's a U.
U. It's called a parabola. Is this linear?
No.
No, it is not linear. What part of this equation makes it nonlinear? Well, there is an exponent on x. It's a function. That equation, y equals x squared plus 1, is, yes, a function. Because our rules were it needs to have an x and a y, which it does. And if there's a variable, it can only be on the x, which it is. This is a function. It's just a non-linear function because there's an exponent,
No linear
it's
function.
not linear. Let's try this one. Number 2. We're going to substitute into x.
Oh.
My first value is -4. So I am going to do negative, no, not negative, 1/2, nope, 1/2 times -4. 1/2 times -4.
What?
1/2 x, and x is -4. What's the same thing as multiplying by 1/2?
You're dividing by 1/2.
1/2 times.
Multiplying by 0.5 or dividing by 2.
2.
Both, all of those are the same. So what's 1/2 of x? What'd you get?
-2.
-2. Good.
Wait, what?
So this is -1.
What's half of -2? -1. What's
How are you getting this?
0.
You took the calculator.
Zero.
I didn't see how you did it.
0.
What?
half
12.
of 0
0.
is 0.
Is this a homework?
What's half of 2?
1.
1.
And what's half of 4?
2. Look at me.
You're multiplying 1/2 times the x value. Or, same thing as multiplying by 0.5 as multiplying by 1/2. Same thing is dividing by 2. X divided by 2. Now let's plot it. -4, -2, -2, -1, 0, 0, 2, 1, and 4, 2.
It's a line.
It is a line. This is linear. And it's because 1/2 is the coefficient of x. What's that called? What have we been using that as? The coefficient of x is where we find the what of the graph?
Y.
The slope.
Hi, coach.
There's the slope.
Say Y.
There's a slope.
Hey,
Okay, next.
Anybody got a charger out of you?
computer?
Nope.
Phone charger.
Wait, what about the question underneath the graph?
We'll go back to it.
What about that?
Okay, here we go. Linear functions. Ready? We'll go back to it. Linear functions. So, to determine if something is a linear function, it has a graph that is a line. If you're looking at a picture, you're looking at a graph, you can determine yes or no, linear or nonlinear, if it's a line. Has to be straight. Well, that's what a line is. A line is straight.
No, I don't.
If it's
I hate those.
an equation,
This one has one.
it says y equals mx plus b. Or it's in some form of that. Again, a linear function, if it's a graph, it's a line. It makes a line. You look at it and you say, yes, that's a line. No, that's not a line. If it's an equation, it must look like this, or some version of this. Y equals mx plus b. M is your what? Slope. And plus or minus b, intercept.
What's Y?
So the x and y variables mean that it's on a graph. Means that you can plot points. Because this is going to be a number, right? You're going to have like y equals 1/2 x plus 3. Yes?
Yeah.
X is the variable that goes into the problem. That's part of the ordered pair, the number. And y is the answer that comes out of it. That's the other part of the ordered pair. So you're going to be given sometimes a graph, a picture, and they're going to say, hey, is this picture linear? And you're going to say, yes, it's linear because it makes a line. Or no, it's not linear because it doesn't make a line.
No.
You're going to be sometimes given an equation, and they're going to ask you, hey, is this linear? And you're going to say, yes, it's linear because it's written y equals mx plus b. There's a slope and an intercept. Now, it might be 0 intercept. It might be missing, but that's still an intercept. If you're given a table of values, you can tell it's linear. If the change in y over the change in x is always the same in the table, one table at a time. If you're given a table,
I'm stupid.
if you're given a table, the change in y over the change in x is always the same. And that, if you want to turn back to page 33, here's a table, right?
Yep.
So my change in y from 3 to 4 is 1, and 4 to 6 is 2, and 6 to 7 is 1. Now, you could say, oh, wait, I'm going to stop. And this is long because it's supposed to always be the same. They should all be the same number. Except you can't stop. Because over here, the change in x from here to here is 5. From here to here is 10.
And then back.
And then it's back to 5. And if you look, 1 over 5 is equal to 2 over 10. So this is linear because it's always the same. Even though they're different values, right? Even though they're different numbers, when I put them into that slope and simplify, it equals out. If it is non-linear, what would the graph look like?
Now changing X.
No slope? Mountains.
If it's non-linear, be as generic as you can. Not a line.
Not a line.
Shh, listen. It could look up and down and up and down and up and down. It could look like a U. It could look like a V. It could look like a circle. It could look,
Like me.
right? I mean, there are so many non-linear examples. It's just easier to say a non-linear function is not a line. A non-linear equation, here's what you need to remember. A non-linear equation has an exponent.
I'm sorry, Miss Long.
On x, right? Because it's a function. Has an exponent with the x. It could be x squared. It could be x to the third. It also could or have x in the denominator. Where's the denominator?
Can't see. This has to be.
Bottom of a fraction.
Oh, a giant calculator.
Okay, time to go to lunch.